Hello students, this is Jagan Babu, Department of EC, Assistant Professor, RMD Engineering College, Kavarapete. We are going to see the subject DSP, Digital Signal Processing subject. Our subject code is 22EC601, Digital Signal Processing, Lab Integrated. This subject for third year, 6th semester students, even semester they are studying. We are discussing the unit number 3, FIR filters, finite impulse response filters, shortly called as FIR filter. Topic we are going to discuss in the FIR filter is frequency response of linear phase FIR filter. The advantage of the FIR filter, question will be raised. The answer will be, first point, it's a linear in phase, or you can say it's a linear phase FIR filter. It's a keyword. Once you take the IR filter, it's not linear in phase. Linear phase FIR filter, we're going to see that today's topic in the third unit, FIR filter is frequency response of linear phase FIR filter. That first we need to understand what is called linear phase FIR filter. Let impulse response be h of n. So take my transfer function h of z for the z transform. H of z is equal to summation n equal to minus to infinity h of n z power minus n. For this, h of omega is equal to summation n equal to minus infinity h of n e power minus j omega n. For FIR filters, h of omega is equal to summation n equal to 0 to n minus 1 h of n z power minus n. H of omega equal to summation n equal to 0 to n minus 1 h of n e power minus j omega n. That's called frequency response. You know very well, instead of z, it's nothing but e power minus j omega. Depending on the value of capital N and the type of the symmetry of the impulse response, that is called the FIR sequence. Here, there are 4 possible types of linear phase FIR filters are there. For any FIR filters, h of omega equal to summation n equal to 0 to n minus 1 h of n z power minus n. Yes, replacing the z as in a discrete time Fourier, it becomes e power minus j omega n. Depending on the value of the n should be, it's not like an IR filter, n should be some value, we can be take some, it's a complexity. But in FIR filter, you're going to find out the samples for 100, 500, even 1000, n number of samples. Depending on the value of the n, the type of symmetry of the FIR sequence, here are 4 possible cases. Based on the n only, they are splitting this FIR filter into 4 cases. Let me list out. Case number 1, symmetric when n is odd. Case number 2, symmetric when n is even. Case number 3, antisymmetric when n is odd. Case number 4, antisymmetric when n is even. There are 4 cases. One is symmetric and antisymmetric, other one is even and odd. If it is a symmetric, it will be even and odd. It's antisymmetric, it's a even and odd. Once we are solving the derivation problems in this third unit, mostly of the problems are symmetric in nature and most of the n value are odd values. If you have the even values, you can solve, but all the values are odd values. It may be response in ideal as well as in the linear phase. Therefore, the 4 cases which are going to deal where the most linear phase will be satisfied only in the n is equal to odd for the symmetric responses, symmetric values of FIR filters. Symmetric for n equal to even is there, but n equal to odd for the sample satisfying only in the symmetric. Similarly, for n equal to odd for the antisymmetric, n equal to even for antisymmetric problems are there, but problems all belongs to only symmetric in nature. If you have 10 samples or if you have 9 samples, first 4 and last 4 always be same. In between the middle value you will be finding using the LH rule, hospital rule, L hospital. Omega P passband frequency in radian, omega S stop band frequency in radian, omega C 3 dB cutoff frequency in radian, lambda stop band parameter, epsilon passband parameter, del P passband error, del S stop band error. So all these values all the denoted and notated terms are frequently using for the problems. Design FIR filter with the passband frequency of, stop band frequency of, 3D cutoff frequency of, and stop parameters of, passband parameters of, passband error of, stop band error of. For the cases of the symmetric for n equal to odd and n equal to even, anti-symmetric for n equal to odd and n equal to even. To calculate again samples for the linear phase as well as the ideal phase. After that, you need to find the H of Z. Once calculated H of Z, you need to draw the linear phase structure. All the FIR filters are linear in phase. So defaultly, you will get the answer in linear section. Hope you will understand this video, right? This is very important. The 4 cases, if you are very clear, you will understand this FIR filter problems thoroughly. Thank you, students. More videos we see in the next videos.